Hello and welcome to another one of D's ADD videos. Today we're going to look at the concept of area of surface revolution. Whenever you rotate a function about an axis, a three-dimensional object that has both a volume and an area is created. So I'm looking at this line y equals x, and when I rotate it about the y-axis, this line that I'm drawing right there between 1 and 4, I get this cone shape. Okay. And this cone shape has a volume, that's a separate video, but it also has a surface area. If you were to take this cone that is formed and cut it on its side and roll it out, what you would get is a big sector of a circle, okay? Not all of the shapes will be known formulas for them, so let's get a more general way of finding this surface area of revolution. There's a general formula that depends on which axis of rotation that you use. If you use the x-axis rotation, then it's one of these two formulas. Notice that the 2 pi y is the same. It's the ds portion, the differential segment, that will differ. So it all depends on whether your function is given in terms of x or y. If your function is given in terms of x, in other words, it's y equals x squared plus 2x blah 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 blah, then what you do is you end up doing 1 plus dy dx squared, and it's in terms of dx, so you have to substitute. Whereas the same rotational axis and the functions given in terms of x equals y blah 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 blah, doesn't matter what the function is, then in that scenario we have to do dx dy squared, and it's going to be a dy integral. So it doesn't make sense to substitute that y in because it's in dy. All right. Now, if we look at the y-axis rotation, the formula changes. It's always the opposite in the main formula. So if it's a rotational axis of y, it's 2 pi x on both scenarios. And depending whether your function is in terms of x or y, you will be able to plug in the right differential segment. So if it's y equals something, you're going to have to do dy dx, integrals in terms of dx. And no, you don't substitute, because it doesn't make sense for you to have something y here and this all be in terms of x. They have to match up so you can integrate. You have yet to learn how to integrate multiple variables. And then the last scenario is if you have rotational axis of y, the function's x equals, then your differential segment is in terms of dy, your derivative is dx dy, and yes, you must substitute because you can't have y's and x's. All right? So I hope that's clarified the concept of the area of surface of revolution. Make sure you check out the examples to further clarify any confusion that you might have. The most important part, you got to practice, okay? So do as many problems as you can and it'll start to click. Thank you and have a nice day.